Hello everyone. In this video, we are going to discuss about exercise question 6.4 from the chapter 6 Systems of Particles and Rotational Motion, class 11 Physics. See, the question is, show that the area of the triangle contained between the vectors vector A and vector B is 1/2 of the magnitude of vector A cross vector B. So you see, let us consider two vectors. Vector A, that is the tail of vector A is O, head of vector A is A. Okay, then we are considering another vector, vector B, whose tail is at O and head is at B. Okay, so we are considering two vectors, vector A and vector B. Let the vectors vector A and vector B represent the two adjacent sides of a triangle. That is, we formed a triangle by using these two vectors, by joining these two ends, and so that we are getting a triangle OAB here. Okay, and let us consider the angle between the two vectors vector A and vector B as theta. And let us consider the height of this triangle, that is AC, which is equal to H. So you see, in this case, these two vectors form a triangle. We want to prove that the area of this triangle, that is equal to 1/2 of, that is half of the magnitude of vector A cross vector B. So you see, in this triangle, OA, that is actually the magnitude of vector A, we can take it as simply A. OB, which is the magnitude of vector B, we can just take it as B. Okay, then AC is the height of the triangle, which is H. Then angle AOB, which is equal to theta. Now, let us consider this triangle OAC or OCA. Let us consider triangle OCA. Okay, OCA. We are considering this triangle. So, in this triangle, if you find out sin theta equals opposite side by hypotenuse. Opposite side is actually AC, because you see this is a right angled triangle. So, opposite side is AC divided by hypotenuse, which is having hypotenuse is actually OA. Okay, so you see from this we can write AC equals OA into sin theta. Alright, so what is this AC? AC is actually the height H. So H equals, what is OA? OA is actually the vector A. So OA side will have the magnitude of vector A, which is simply A into sin theta. Okay, so H is equal to A sin theta. Alright, H is actually what? AC. So AC is equal to A sin theta. Now you see, what about the area of triangle OAB? The area of a triangle is actually equal to half BH, that is half into base into height. Okay, so area of triangle OAB, that will be equal to half into base into height. So this is actually equal to half into base. Base means OB. Okay, into height. Height is actually AC. Okay, so this is actually equal to, that is area of triangle OAB equals half into, what is OB? OB is actually vector B. So, the side OB will be equal to the magnitude of vector B, which is B, into AC. AC is the height, which is H. Right. Now, you see this can be written as half into B into, what is H? H is A sin theta. So, A sin theta. Okay, that is, you see area of this triangle OAB, this is actually equal to half into A into B sin theta. Okay, so area of triangle OAB, that is equal to half AB sin theta. What we want to prove? We want to show that area of this triangle, that is equal to half of the magnitude of A cross B. Okay, so you see here the area of triangle OAB equals half AB sin theta. Now, what about the cross product of two vectors? That is vector A cross vector B, that is actually equal to A into B into sin theta n cap. N cap is a unit vector. Okay, so you see n cap is a unit vector which is perpendicular to the plane containing the two vectors vector A and vector B. Now, what about magnitude of vector A cross vector B? Modulus of vector A cross vector B, or magnitude of vector A cross vector B means we don't want to consider the direction, just the magnitude, that is AB sin theta. Okay, so you see, let us combine or just let us compare this equation and this equation. Suppose I am considering this as equation number 1 and this as equation number 2. So you just compare equation number 1 and 2. You see, this is magnitude of vector A cross vector B, that is AB sin theta. This is area of the triangle formed by vector A and vector B, that is equal to half AB sin theta. So you see this half AB sin theta, which is actually the area of triangle OAB. So this is actually equal to half into AB sin theta is actually what? Magnitude of vector A cross vector B. Okay, that is the area of this triangle OAB, that is actually equal to half of the magnitude of vector A cross vector B. Okay, that is what we wanted to show. Okay, so we showed that the area of the triangle contained between two vectors, vector A and vector B, that is equal to half AB sin theta. That is actually equal to what? 1/2 of the magnitude of vector A cross vector B. Okay. So I hope it is clear to you. Thank you.